A Dippin' Dots vendor at Walt Disney's Magic Kingdom Park sells Dippin' Dots and sugar cones. When he prepares a customer's order, the vendor scoops Dippin' Dots from a freezer into the cone until 4/5 of the cone's depth is filled with Dippin' Dots. To elevate his sales, the vendor advertises an efficiency guarantee in which he promises that a customer's order of a single, any-size cone will be prepared within 60 seconds. If this time constraint is not met, the order is free of charge to the customer. If the depth of the Dippin' Dots in the cone as the cone is being prepared rises at a rate of 0.04 centimeters per second, will a customer who has ordered one regular-sized cone receive his order free of charge? Each regular-sized cone has a height of 11 centimeters and a radius of 3.5 centimeters, and the proportion of height to radius remains constant throughout the cone. Hence, the height is about 3.14 times the radius at all depths of the cone. Assume that the preparation of a regular-sized cone only requires pouring the Dippin' Dots into the cone.
The height of the cone is 11 centimeters, and the cone must be filled up 4/5 of the way. Therefore, you must multiply the height of the cone by 4/5 to get 8.8 centimeters. The volume of a cone is 1/3 times pi times the radius squared times the height. The ratio between the height and the radius shows that the height is always 3.14 times the radius. Using the ratio, plug the new value for the radius into the volume equation. Simplify the equation to 0.106 times the height cubed.
Take the derivative of the volume equation using the power rule. This will give you 3 times 0.106 times the height squared times the rate of the height. Plug in 8.8 centimeters in for the height and 0.04 centimeters per second for the rate of the height. Then solve to get 0.985 centimeters cubed per second as the rate of the volume. Use the volume equation to find the volume of the Dippin' Dots in the cone. Plug in 2.8 centimeters for the radius and 8.8 centimeters for the height. Solve to get 72.248 centimeters cubed as the volume.
To find the time it took for the vendor to prepare the Dippin' Dots cone, divide the volume of the Dippin' Dots by the rate at which the volume is increasing. Solve to get approximately 73 seconds. Note that this is greater than the allotted time of 60 seconds.
To make this vendor's cart, we used 2 wheels, a wooden skewer, a small shoebox, a birthday party hat, colored pom-poms, and a measuring cup. The wheels were attached to the ends of the skewer and attached to the box. A compass was used to create a circle on top of the shoebox, and the circle was cut out using an X-Acto knife. The cone was placed inside the resulting hole. The pom-poms were placed inside the box representing the Dippin' Dots, and the measuring cup was used as a scooper for the Dippin' Dots.